Dr. Ejiro Umaka.
Have you ever wished you had a time machine? If you had one, what point in time would you go? Personally, I'd go to the early universe, about 1 millionth of a second after the Big Bang. At this time, our universe was filled with a hot soup of free quarks and gluons known as quark-gluon plasma. The particles that make up this soup are the tiniest building blocks of matter. They make up the protons of atoms, which makes up cells, and, you guessed it, makes us. So everything we see around us, including you and I, comes from particles that make up this soup. Amazingly, at Brookhaven National Laboratory, we can turn back the clock with a machine called the Relativistic Heavy Ion Collider, or RHIC for short. RHIC collides nuclei at nearly the speed of light. The collisions are so energetic that they melt the protons within the nuclei, releasing free quarks and gluons in a quark soup, the soup of our early universe. To study this soup, I used sprays of high-energy particles called jets. These jets zip through the soup, revealing unique information about its properties. Incredibly, our experimental findings showed that particles within the soup act like they know about one another, like a school of fish collectively responding to a disturbance. This was a surprise, because we had expected free quarks and gluons to barely interact, like molecules in a gas, unconcerned about what their neighbors are doing. To confront our understanding of the fundamental interactions between quarks and gluons, we need to turn again to experiment and collect more data. Because resolving small distances, like the scale of quarks and gluons, requires that we shoot many more jets at the soup with sufficient spatial separation. To this end, I and a group of scientists constructed a detector at RHIC known as S-Phoenix. It's a state-of-the-art jet detector, 3 stories tall, and equipped with the latest technologies for capturing snapshots of the quark soup. It's recording several millions of jet probes, which will provide a finite-scale view of the quark soup, allowing us to study its microscopic nature. Understanding the nature of matter at this tiny scale can lead to discoveries that revolutionize our world. The way we've exploited our understanding of the electron's behavior at the atomic scale to power today's technologies. So, when we go back in time and study the Big Bang's quark soup, we're opening a doorway to future technologies, and we're unlocking the secrets of the tiniest building blocks of matter that made us and the vast universe we call home.